we started matrices in our last class, we look at the definition for matrices, and we also look at some terminologies used with matrices. We also look at some characteristics of some matrices and so on. From there, we'll be able to look at how the matrices look like. And one of the definition or the characteristics that we look at is we look at identity matrix. We look at different type of matrices, equation, zero matrices, and so on. Now, I want to continue from where we stop. Today, we want to start a very important topic or continuation of matrix, which is matrix operation. Now, do you all know in mathematics we have operation? When you are dealing with math, you can perform different operation. We have addition, subtraction, multiplication, and so on. We can also do the same thing to matrix, like the way we normally do for our integer, our rational number, and so on. Now, let's see. These are the operations we can perform with matrices. We have our addition, subtraction, multiplication. Those are the major operations in matrices. Now, I'm going to be using an example to explain this since we have defined matrices. Now, take note, before you add or subtract any matrices, the matrices must be of the same order. That is the same number of column and the same number of row before you can add or subtract two matrices. Let's see. Okay, before that, before we go to addition and subtraction, let's look at how to use a scalar to multiply matrix. That is the first thing we use before we go to addition and subtraction. If you have a matrix, then you want to multiply with a scalar. A scalar means any number, any constant to multiply matrix. That constant is going to multiply all the elements of the matrices. Now, let's look at an example to showcase that. Example 1. We have a 2 by 2 matrix. Let A equals 2 minus 1, 6, and 5. And we have a constant K, which is equals to 3. Then we want to use that K to multiply A. That is, we want to find 3A. Then this is how it will look like. Look at the solution. That is, we are going to use that 3 to multiply the whole matrix A. That 3 will multiply each of the element of matrix A. That is why we have 3 times 2, because the first element A11 is 2. 3 times 2 will give me 6. The second element A12 is minus 1. 3 times minus 1 will give me minus 3. 3 times 6 will give me 18. And 3 times 5 will give me 15. Do we understand that? Do we understand? Yes, okay. That is how to use constant to multiply matrices. Now, let's now go to addition of matrices. Now, as I said, before you multiply before you add 2 or more matrices together, the first thing is that the matrices must be of the same dimension. What does that mean? It must be of m by n matrices, the same matrices. It must have the same number of row and the same number of column. Then the matrices that you are going to produce when you add, we also have the same number of row and the same number of column when you are dealing with addition. Let's look at example to showcase that. Let's see. Look at these matrices. We are given 4 different types of matrices. We have matrix A, 3 by 3 matrix. We have matrix B, 3 by 3 matrix. We have matrix C. This is 3 by 2, 3 by 2 matrices. And we have matrix D, 2 by 3 matrices. Do you get that?
Yes.
Okay, we now want to add A plus B. We want to add matrix A and matrix B. Can we add matrix A and matrix B?
Yes.
The answer is yes, because it has the same dimension. Matrix A is 3 by 3 and matrix B is what? Is 3 by 3. I can add. Now, if I want to add, I will add corresponding value of the two matrices, that is the same position. That is, A plus B is going to give me the first element of A is 1. The first element of B is also 1. I will add the two together. I must add the corresponding values. That is why I have 1 plus 1. The second element of A, which is 3, A1 2 is 3. And the second element of B is 5. I will add also together 3 plus 5. And I will do the same thing for all other elements. Then I will produce another matrix. This new matrix is now 2, 8, 14, minus 1, 8, 8, minus 1, 3, 2. Do you see that the new matrices produced is also of dimension 3 by 3? Do we see it?
Yes.
Okay, it means whenever you want to add, that is the first condition. You must take note of it. It must be of the same dimension. Now, the second one, Roman figure 2, C plus D. Can we add C plus D? Can we have C plus D?
No.
No, sir.
No. Why?
Good, which one?
Because C is 3 by 2 and D is 2 by 3.
Yes, we cannot add C. Please, I hope others are also following. It's not only one person, no. Others should also following. We can add C. We cannot add C and D because your C is 3 by 2 matrix and your D is what? Is 2 by 3 matrix, which failed with the what? With the condition of addition that they must be of the same dimension. We cannot add that. That is why we said C plus C is impossible, because the two matrices do not have the same number of row and column. C has 3, yes, we see now C has 3 row and 2 column. That is why we call it 3 by 2. Also, D has 2 row and 3 column. That is why we call it what? 2 by 3. And we cannot, addition of that 2 matrix is not possible. Now, let's go to properties of addition. Now, we have some properties that we want to look at of addition. The first property, if we have A, B, and C to be 3 matrices with the same dimension or order, and K is a scalar. Look at the condition. We said A, B, C, they are of the same dimension. It means we can add any of the 3 because they are of the same dimension. We have been given this condition. It is permissible that we can add the 3 because they are of the same dimension or order. Now, we now have K is a constant. Then, these properties, the first property is called commutative property. That is, when you have 2 matrices, A plus B is going to give you the same result as when you add it as B plus A. You can try it. The example we did the other time, we have A plus B, we do that. You can also check B plus A. It's going to give you the same result. And that property is what is called commutative property. Are you with me?
Yes.
Okay, and you get it. Now, the second property we want to look at. Yes? Are you asking question?
Sir, if it's 3 that they gave you, like A plus
Now,
B plus 3, if you add
that
A
is
plus
the second property that I want to look at now. That is what is called associative property. Now, associative property and commutative property, they look alike, but whenever you are talking about commutative, you talked about 2 variables. Do you understand? A, B. But when you are talking about associative, you talk about 3 variables. And that answers your question. That is, when I have matrix A, B, C of the same dimension, then I can decide to add any of them at any point in time. That is, if I add A plus B, the result that I got, if I add A plus B, I'm going to get a matrix. The result that I got, if I add it to C, I'm going to get another result. It's the same thing of adding B and C, the result, then you add it to A. Do you understand?
Yes.
It has answered your question, Abi.
Wait, is it also the same thing as adding A plus C, then you add it to B?
Yes, it's going to give you the same answer. That is the property of what? Associative property. Any of the 2 that you pick at first, is going to give you the same answer if you add it to the third one. You understand?
Yes.
Do you get it? Okay. Now, the next one is what is called distributive property. This distributive property is that when you have a constant or a scalar, multiplying an addition of, when you add two matrices together and you multiply the result with a scalar, it's going to give you the same thing as if you multiply one of the matrices with the scalar plus the second matrix with the scalar, you are going to have the same result. And this property is what is called distributive property. I hope you can see my results. You can see my board. You can see my screen.
Yes.
Okay. Look at that K. K, if you multiply with, when you perform the operation of A plus B and you multiply with K, it's going to give you the same result as when you multiply K and A plus K and B. It's going to give you a result. And this property is what is called distributive property. It means those are the properties of addition. Let's see the last one. The last one here is called identity property. In our last class, we discussed about zero matrices. Do you understand? You remember that we discussed zero matrices in our last class? Now, when you have a particular matrices and you add it to zero matrices, you are going to have that matrix back. If you have a matrices A, you now add it to zero matrices. That zero matrices must have the same dimension as your A. Then if you add the same thing together, then it is going to give you the matrices. You remember when I was talking about, you remember last class that we are talking about identity, that if you use an identity to multiply a matrices, you get that matrices together. Do you understand? That is the same thing with addition. When you add zero matrices with a matrices, you are going to get the matrices together, and that is what is called identity property. Those are the properties of addition of matrices. Now let's look at an example. Let's just look at the example to play with this. We have matrix A and B. If I add these two matrices together, A and B, the result is 9, 11, 8 minus 5. Now, let me now do for B and A, B plus A. Look at B plus A. When I add B plus A also, I have my result also to be 9, 11, 8, and minus 5. Meaning, is going on the quantitative property of the matrix is what? Odd. Do you understand? Do you understand it?
Yes.
Yeah, I've shown the property. Now you can try the other property yourself. Just pick 3 matrices and perform the operation. Also, you can pick a constant and use it to what? To show that is the matrices addition is what? Is also distributive. You can also do the same thing to what? To the identity. Just pick a matrix, an n by n matrix, and you pick an zero matrices also. Add it together. You see that it's also going to give you the n by n matrices that you pick.
Okay, sir.
Now, the next thing that I want to look at, okay, look at this matrices also. The one I said you should do, K, a constant. I don't even know, I forgot that I have the example here. If I have a K, look at these matrices now. I want to open the bracket. I will use 2. If I add these two matrices together, I have the matrices together. The result give me this. You see it now. I add A plus B. That is the result. I now use the result. I use 2 to multiply the result. At the end of the day, I have 826, 822, and 844. Now, let's see the second one. If I now do it 1, 1, I use 2 to multiply A, plus I use 2 to multiply B. At the end of it, and I add it together. Do you see that I have the same result? Do you see that I have the same result?
Yes, sir.
Okay, this is what is called distributive property. I've shown the distributive property. You can do the remaining 2. It's equal. Now, let's now go to subtraction of matrices. We want to look at subtraction of matrices. Subtraction of matrices does not really hold in matrices. Subtraction is like an addition also. whenever you want to subtract matrices, it's just as if you are saying, I want to find A minus B. If I want to find A minus B, it's the same as saying I want to find A plus into bracket minus B. Do you know that?
No, sir.
I said if I want to find A minus B, it's the same as saying A plus minus B. You know that
Yes.
now, because minus times plus will
Yes.
still give you minus.
Minus.
Yes. Now, in matrices, when you want to find A minus B, the first thing you need to do is that your matrices B, you first use -1 to be the constant to multiply the matrices, then you add it together, the result. Do you understand? Do you get that?
Yes, sir.
Can you see my screen?
As -1B.
Yes, thank you. You will use -1 to multiply your matrix B. Then the result, you add it to A. That is A minus B. That is why we just said, just as an addition of matrix, if A and B are two matrices of the same order, we define the difference as the sum of A and minus B. Yes, because the sum of A and minus B will give you A minus B. And I've shown that, which is what? A plus what? Minus B. Now let's look at an example to showcase that. Look at these two matrices. This A is what matrix? What's the order of matrix A, class?
That's it. I'm
2 by
fast.
3.
Is what?
2 by 3. 2 by 3.
Yes, thank you. 2 by 3. Now we have matrix A to be 2 by 3. We have matrix B to be 2 by 3. Then we want to subtract. Now, for me to subtract these matrices, it's the same of saying I want to add matrix A and matrix minus B. The first thing I will need to do is I will multiply matrix B by -1. Your -1 will just add as a scalar. We add as a scalar. Then I will use it to multiply my B. Then I have something like this. If I use it to multiply my B, then I have, look at it now. If I use minus to multiply, all this will change to minus. Or you can also subtract it direct. You have the same result also. You can subtract it, but it's the same as saying -1 to multiply it. And at the end of the day, you have your result. That is how to subtract matrices. Any question?
Yes.
What's the question?
No, sir.
Sir. Wait.
No, sir.
Someone wants to ask question. You are saying no. Let her ask now. What's your question?
Okay, sir.
Sir. Okay, is it because you said -1? -1 to be, that was maybe to be plus what?
Yes, thank you. Because what we assume we want to use -1 to multiply. That is why we have that plus between. And that is what I explained the other time. You don't understand?
So -1 times minus B is equals to.
Okay, sir.
Yes, it is going to be A plus minus B. That is, we are going to use -1 to multiply B. And that is why we are going to have -5. My minus B will now turn to -5, -4, -1, -2, -1, and 3. Then you add the results together. Please, who is making noise? I will mute everybody now, please. You are making noise.
Stop that now. Stop that.
Now, that is just the how to subtract matrices. You can use any of the two methods. You are going to have the same result. Either you first multiply your B with -1, then you add, or you just subtract A minus B. Any of the two methods, you have the same result. That is subtraction of matrix. Take note, those properties of addition that I gave you does not apply to subtraction. Subtraction of matrix is not commutative. Subtraction of matrix is not associative. Also, subtraction of matrix is not distributive. Also, subtraction of matrix is not what? Is the identity. Zero is not an identity to it. Okay, zero can be an identity to it. Zero can be, if you subtract A minus 0 will still give you A. but addition, commutative, associative, and distributive property does not hold for subtraction. Just take note of that. Now, the next thing we want to look at now is multiplication of matrices. Multiplication of matrices. We want to look at multiplication of matrices. Now, for you to multiply matrices, take note. For you to multiply matrices, the matrices A must have the same number of rows with the column of matrix B. It's not that they must have of the same dimension. No, that is not the condition. No. Like the way we said A and B. Let me unmute everybody so that you can speak out if you don't understand this. Is very, very important. Now, but reduce your noise. For multiplication of matrices, two matrices A and B can be multiplied if and only if the number of column of A is the same to the number of row of B. Do you get that? Class, do you understand? Do you get it?
Don't worry, continue, sir. They will talk if they are not getting it, or they should send message.
Okay, thank you, sir. I said for you to multiply two matrices, the number of the column of the first matrices must be the same with the number of the row of the second matrices. That is, if I have matrix A to be 3 by 2 matrices, then I can only multiply with B if B is 2 by anything, maybe 2 by 3 or 2 by 4. That is, the number of the column of the first matrices must be the same with the number of row of the second matrices. Now, let's look at example to showcase this. Now, look at these matrices. My matrix A is 3 by 2 matrices. 3 by 2, that is, I have 3 rows and 2 columns. And my matrix B is 2 by 2 matrices. I have 2 rows and 2 columns. Since the number of columns in A is the same as the number of rows in B, then I can multiply the matrices. Then I want to find A multiplied by B, AB. Then this is what you are going to have. Look at it here. I have 3, 2. I'm going to use this 3 to multiply. I'm going to use the row, the column of A to multiply the row of B. Or you can also say the row of A, you can use it to multiply the column of B. Any of the two, you have the same thing. But that position must be retained. Now, look at it now. I'm using the column of A to multiply the row of B. The column of A is 3, 4, 1. 3, 4, 5 is the first column of A, while the second column of A is 2, minus 1, minus 3. Now, I'm going to use it to multiply the row of B. The row of B is, the first row of B is 2, 3. The second row is 4 and minus 1. Now, let's start. I'm using the first column of A to multiply the first row of B. That is why I have 3 times 2 plus, and I will add. If I multiply, I will add the second term. 3 times 2 plus 4 times 2. Do you see it? That is the first one. Do you get what I did? Okay, yeah, you can do it in that same way. This is what I did. I used the row of A to multiply the column of B as this example. The row of A, that is why I use it to multiply the column of B. I have 3 times 2 plus 2 times 4. That will give me the first element of the result. The second one, the row of A now is, for the second row, I have 4 minus 1. I'm going to use it to multiply what? This column of A, the first column of B. That is 4 times 2 plus minus 1 times 4 will also give me that. You see the result also. The same thing, the third one, I have 5 and minus 3. I will use it to multiply 2 and 4 in B. 5 times 2 plus minus 3 times 4. I'm done with that first part. I will also do the same thing to the second part. That is, I'm going to use the what? The row of A to multiply the second column of B. Let me start again. 3 for the second column of B. 3 times 3 plus 2 times minus 1. That is the second. I'm using the first row of A to multiply the second column now. Now, I'm going to the second row of A to multiply the second column of B. 4 times 4 times 4. Do you see it? I said I'm using the second one. Okay, 4 times 2 plus minus 1 times 4 times 3, sorry, I'm using the second column. 4 times 3 plus minus 1 times minus 1. That is it. Now the third row of A, 5 times 3 plus minus 3 times minus 1. And the results, you add it together, then you have a new matrices. That is how to multiply matrices. The condition must be met. And what is the condition? The condition is your number of column in matrix A must be the same with the number of row in matrix B. That is how to multiply matrices together. Now, any questions so far before we move on? Any question? Do you have any question? You are unmuted already, or you can talk, or anybody can talk. Okay, I assume there is no question. Now, let's continue. We want to look at the properties of multiplication now. Properties of multiplication of matrices now. The first property is also what is called, okay, there is a commutative property. I think I will meet the first one. Commutative property of matrix. If you have matrix A multiplying by B and matrix B multiplying by A, it is not commutative. That is why you don't see it there. It's not commutative. But we are going to have associative property. If I have matrix A, B, I use it to multiply C. It's the same as saying matrix B, C, and I use it to multiply what? A. That is the first property under multiplication. Associative property old. Now, the other one is distributive property. Left distributive property, that is, we are going to start from the left. A into bracket B plus C is going to give you, if you multiply AB plus you multiply AC. That is also another properties of multiplication. Now, it's also right distributive also. If I'm starting from the right, I will have AC. We also A plus B multiplied by C. We also give us AC plus B plus C. That is what is called the right distributive property of matrix multiplication. Now, we want to look at matrices that involve equation. But before we go that, any questions so far? Are you guys with me? You guys should respond. If you are getting it, let me know. Class, can you hear me? Does I don't think these people are hearing me.
Connect.
They can hear you.
Are you with me?
They can
You
hear
can
you.
hear me. Okay, I just want to confirm that I'm not just speaking on the mic alone. Why? Please, do you understand everything we have been saying? Can I continue?
Yes, sir.
Okay. Now I want to look at matrices involving equation. Let's assume we have a quadratic equation or a linear equation, and we are now given a particular matrices to apply it to that equation. What are you going to do? Let's assume you are given an f of x, a function of what? A function f of x is equals to, let's say, x plus 2. They now ask you to find f of a, and where a is a matrix, then what are you going to do? It's very simple. Let's look at example to showcase this. Let's assume you are given this matrix. Let A equals 2 by 2 matrix, 2, 1, 1, 1. If f of s is equal to, this is a quadratic function or a quadratic expression, then want to find f of A. It's very easy. What does it mean? If you want to find f of A, what it means is that anywhere you see your s, you put your A. And you remember that your A is a what? Is a matrices. Then I'm going to have A squared plus 2A plus 3 in form of matrices. Your A squared means you should multiply matrix A twice. Your 2A means you should use 2 as a constant to multiply your A. Plus 3. Since 3 is just what? It's just a constant. Then you are going to use that constant 3 to multiply, to make it to be a matrices. You use it to multiply an identity matrices. Let me call again. Let me recall. I said if you want to find f of A from this question, you are going to, anywhere you see your s, you just substitute your A. That is, f of A will just be equals to A squared plus 2A plus 3. Now, in form of matrices, your A, since your A is a matrices, it means you are going to multiply the two matrices. A squared means multiply matrix A and matrix A, that is A squared. Plus, you add it to 2A. 2A means use constant 2 to multiply matrix A. You see that it's still going to be of the same dimension. Why the last number plus 3? Since 3 is just a constant, and I want to make that 3 to be in form of matrix, then I will multiply the 3 with an identity matrix. It's 1, 0, 0, 1, since the matrix A is 2 by 2 matrices. Let's look at the solution. Look at the solution. A squared. My A squared is 2, 1, 1, 1. Then I multiply it. 2, 1, 1, 1, 2, 1, 1, 1, multiply 2, 1, 1, plus 2A. 2A will give me 2 times 2, 1, 1, 1, plus my 3 is a constant. Then I multiply with an identity matrix, 1, 0, 0, 1. Then at the end of the day, if I perform the operation, after multiplying A squared is going to give me this. After using 2 to multiply the A, I will have this, plus if I use 3 to multiply an identity. And at the end of the day, the result of the equation give me 2557. Do you understand? Do we understand? Okay, I assume you understand. To tell you, as I said at the beginning of this course, I said this matrices of a thing is not only going to help you to pass your WAEC, also is also going to help you when you get to our institution. Just take note of those things that are going together. Now, the next thing we want to look at, we also want to look at some also properties of a matrices. The first one we want to look at is, have I talked about transpose of a matrix to you? Did I talk about transpose of a matrix? In our last class, did we talk about transpose of a matrix? Class, respond now. Do we talk about transpose of a matrix in our last class? Do we talk about transpose of a matrix in our last class?
Earlier he called you.
I think we talked about transpose of a matrix in our last class, where I said if you have a matrix A, the transpose of matrix A is what? You are going to change the row to colon, and you change the colon to row. I think we discussed about transpose of matrix in our last class. Now, we now want to use that to also define some terminologies of matrix. What we want to look now is symmetric matrices. When is a matrix said to be symmetric? We said let A be an n by n matrices, that is a square matrices. Then A is symmetry if and only if A is equals to A transpose. Once again, we said a matrix is said to be a symmetric matrices if that matrices is also equals to its transpose. And I've explained transpose in our last class. That is, when you have a matrices, just change the row to the column, and the row will turn to column, column will turn to the row. If I have, let's say I have my matrix A to be A11, A12, and A21, A22, then the A transpose of that matrix will just be what? A11, A21, A12, and A22. That is just the transpose. You change the row to column and you change the column to row. Now let's now look at this. Look at this matrix example. We have a matrix A. Let A equals, this is 3 by 3 matrices. 2, 1, 6, 1, minus 1, 3, 3, 6, 3, 4 to be a matrix A. Then we want to show that this A is symmetric. And for me to show this A to be symmetric, I need to find what? A transpose. And if I find the A transpose, if it's equals to A, then the matrix is what? Is symmetric. Now, class, what is A transpose from this matrix? The A transpose of this matrix will be what? It's going to be 2, 1, 6, 1 minus 1, 3, 6, 3, 4. Now, if you find A transpose of this matrix, A transpose will give you 2, 1, 6, 1 minus 1, 3, 6, 3, which is still the same thing with my A. I can easily say that this matrix is what? Is symmetric. Look at it now. This is A, and the A transpose is what? A transpose also give me the same thing as A. Then we said the matrices is what? Is symmetric. We said the matrices is symmetric. Now, the last thing we want to look at is what is called skewed symmetric. We have talked about symmetric, then we need to talk about the skewed symmetry. A matrix is said to be skewed symmetry if the matrix A is equals to minus of the A transpose. Minus of what? A transpose. Then we said the matrix is what? Is skewed symmetry. Now, do we get that? Let's look at example to showcase the skewed symmetry matrix. If my matrix A is equals to 0, 2, minus 1, minus 2, 0, minus 4, 1, 4, 0, then if I find the matrix A transpose will give me 0, minus 2, 1, 2, 0, 4, minus 1, minus 4, 0. You will see that your A is not equals to A transpose. A is not equals to A transpose, then this matrix is not what? Is not symmetric. Since A is not equals to A transpose. But if I use minus to multiply A transpose, then it's going to be equals to A. If I use minus to multiply my A transpose, then it's going to be equals to what? A. Then I will now see that my A is equals to minus A transpose, which is what? What we call the skewed symmetry. Any questions so far? Please let us ask questions from what we have done since morning. We are going to stop here because I don't want to start the next area or the next aspect of this matrix, which is the determinant. We are not going to be able to finish the determinant before time. We are going to stop here. In our next class on Monday, we are going to start determinant. We are going to look at determinant of matrices. Also, we are going to look at inverse of matrices and how to use matrices to solve simultaneous equation. You know, mathematics is very flexible. If they give you a question in theory and said, solve this simultaneous equation, you may decide not to use the normal conventional method of solving. That is using maybe linear method, substitution method, or any other method that you know. You can also use matrices and you get the same answer. And that is what we are going to look at next week. But before we go, please ask question. If you have any question, you can ask now before we end the class. It's 1 o'clock already, 1 minute to 1. I think 1 minute to 1. If you have any question, you can ask. You have the floor now. Any question? Do we have question before we end the class? I'm going to post your assignment today. I'm going to post 2 assignments. The first assignment is going to be based on what we did on Wednesday. And the second assignment is going to be based on what we did today. Please, you need to submit the assignment on Edumodul. Check your Edumodul by 2 p.m. today. You will have seen the assignment, latest to today. Any questions so far? Should I assume there is no question? You understand what you have been saying since morning? Are you guys in the class? I'm not sure if these people are in the class. Oh.
They are responding already. They are saying some of them are in the class. Just don't worry. Leave them. We will know the issue.
Sorry, what's the problem? Let me get the problem. Is it that they didn't understand it?
They have been sending messages. They have been
to
sending
you,
messages.
Abi?
No.
What's the message?
To everyone now. The message is that they are getting it.
Okay. Thank you, sir. I just need to confirm me. Now, please, by 2 today, let's just check our Edumodul platform for our assignment. Please, let's try as much as possible to understand the topic. As I said, it's not only going to help us now, also it's going to help us later on in our academic career. Let us try as much as possible to understand what we have been doing. We are going to end the class now because of time, then we continue on Monday. Thank you for coming. Assalamu alaikum warahmatullahi wabarakatuh.